Yes guys, let's start with the OpenCV library. So let me share the screen to you people. Mm, the session. What do you mean by OpenCV? It's a open source computer vision library. Okay. So originally built for C++ programming. So later extended to Python. Okay. See, OpenCV is a computer vision library. Mainly, like you can see, computer vision applications are like enormous applications are there. Okay, starting with so your mobile phones. So mobile phones like camera, displays. Okay, so all over these places you have an application of image processing involved. Okay, like digital cameras, digital cameras. You have the applications. Okay, then computer scanners, like document scanners, like Xerox machines, what you call, okay, photocopier machines, okay, printer machines, like wherever you have the image based applications, okay, you require these techniques. Okay, and nowadays in like social networking platforms, online marketing, e-commerce, and many more. Medical image processing, okay, uh, satellite image processing. No, like there are n number of areas applications are there where you can find the application of the computer vision is concerned. Wherever you have this application, like you have the application, so there is no area we can say like you don't require the image processing. Okay, like you can say that any number of areas, like even if you take agriculture, so you'll still find the application of the image processing. Okay, like in almost uh, all the areas we have the major requirement of the image processing. Okay, so for this purpose, okay, so what the team did is they built an suitable library, so which can be easily accessed and used for the deployment purpose. Okay, so earlier what used to happen is for each of the library like algorithms required, they're supposed to write the separate programs for each one of them. Okay, instead of doing that, if you have a library, it makes the things easier, and we can make the product development at a faster phase compared to the writing a code from the scratch. For this purpose, okay, so the library which is made completely open source, and it actually built using the C++ programming. It supports the C++ programming. Okay, so that's why C++ is the major programming language used in most of the companies in the earlier days. Okay, but now due to the rise of the Python programming, okay, so the library got extended to the Python also. The same open source library, whatever the functionalities are available in the OpenCV library for C++, almost all the same functions are also available for the Python based OpenCV library. Okay, so this is the brief intro to the open source library, computer vision library. So let us see that library now. So here is the OpenCV library. So like official website opencv.org. Okay, so you have basic courses, like if you want to learn it, you get free sources completely. Okay, So you have a documentation, tutorials are available. They have some Git library. So core functionalities: image processing, image file reading and writing, video input output, high level graphical user interface, video analysis. Like that, many options are available here. Tutorials are available for the OpenCV models. So if you like to, you can go through this documentation in the later stage. Okay. So but as a beginners, what I suggest is you can go to this particular tutorials to read more about the OpenCV library. Okay, so this is the base. This tutorials will give the more complete details like basic documentation along with the complete functionalities for the Python purpose. Okay, even you can get the tutorials for C++ if you are interested. Okay. So like it gives the functionalities like a MATLAB style syntax. It's very similar to the MATLAB. So once we start using it, you will get to experience the same thing now. OpenCV library doesn't comes pre-installed. We need to install the OpenCV library separately. Okay, so we need to install it separately. Like how to install it? Okay, so we need to use the Anaconda command prompt. So we can install it from the Anaconda command prompt. How to open the Anaconda command prompt? Okay, so later on we'll see how to open the Anaconda command prompt. After opening it, you can install it by the command pip install OpenCV. So this is the one command, or we can use the alternate command like conda install. Then there are a few more commands are like forge, I guess. 1 minute. So conda install space -c conda -forge OpenCV. So this is the standard syntax. Either you can go for this syntax or this syntax. So if you are using Anaconda, better to go with this syntax. Okay, otherwise you can go with this syntax. So this directly works for even in the Linux machine. Directly you can use this kind of commands. Okay. So what is Anaconda prompt? How to get that one? You can go here. So this is basically Anaconda navigator, and this one is the Anaconda prompt. I can directly open it from here. But if you don't have that in the taskbar, what you can do is you can just search here Anaconda. So you will get an Anaconda prompt here. Anaconda prompt for the Anaconda 3 version. So just click on that. Manjushri. Okay, audible ideyala? Screen. Okay. So here what you need to do is you can even I not installed it. Okay. See, normally there will be some installation problems will occur when you try to install the OpenCV. Okay. So majority of the people face the issue. Majority of the peoples will face the issue in installing the OpenCV. Okay. So now I'm going with the option conda install -c conda -forge OpenCV. Okay, you require the internet connection to install this. Okay, so just you need to type this command. Automatically the installation will start if you are connected to the internet. Wait for 2 minutes, guys. So it will take installation. So just you need to click yes to proceed the installation. So normally what you have to do is I'll be writing few more commands before that, before you install the Anaconda. So if you are using this command, okay, so try to do this two steps before that one. Okay, so first is updating Anaconda. Okay, how to do that Anaconda updation? You can type conda update conda. Okay, so this will update the Anaconda. Okay, so conda update Anaconda. So this is the updation process that you need to complete it before you begin the installation. So then you try the installation. Now install OpenCV. Okay, so mostly this transaction is going on. Okay, so completed, the installation has been completed. This is again coming back again. So installation completed. Okay, after that you can close this one. Okay, so but before that, if you want to check the whether the installation completed or not, okay, you can just type conda space info to see the all the install libraries. Okay, sorry, this will give the which version of the Python and all that details are available. And there is a one more option to check the uh, Python libraries installed. Just give me a second. Okay, if you are trying conda space list command, once you execute it, it will list all the libraries installed. Whatever the libraries we have installed, that list will be available to us. So this is the command which I tried it now, conda space list. Okay, it is showing all the libraries which are already installed here. Okay, so OpenCV library, if you want to check it, you can see that it is available here. OpenCV, this has been installed. Which version? 4.0.1. So this has been all now installed. So that's it. Okay, installation is completed. So let me go to the next step. See here, so this is the same syntax for other libraries also. Okay, so if you want to install the other libraries like TensorFlow, which will be required for the one more class, Keras, you can install in the same way, like conda install -c conda -forge space TensorFlow. So you cannot directly install the Keras. First you need to install the TensorFlow and then you need to install the Keras. So what is this TensorFlow and Keras? I will be telling these things in the next class. Okay, so along with the deep learning session I will be telling it. But now what you can do is, you can when you are installing this OpenCV, so directly you can try installing this also. Okay, so once you finish this, so try this installation and try one more installation called Keras as well, which will be helpful, required for the deep learning sessions, which will be required for the deep learning sessions. Okay guys. Okay, so this lab session will be onto the OpenCV programming basics. Okay, see, later on I suggest you to use this tutorial. Okay, this is the tutorial which, if you like to learn more about the OpenCV, just refer this tutorial. Okay, so let me start with the new one. So now, so basically I need to import the library. Import OpenCV as CV. Okay. So this is the basic library which will be using it. You can directly import it as OpenCV as import CV2 also. You can directly write. Okay. You can import CV2. Simply you can write import CV2. If you want to import it as a with some other names, you can do that also. But I will be directly importing it as a CV2 library. Okay. So then I will print. So library imported. So let me do this one. At the beginning it will take more time if it is properly installed and if it is in the root. So otherwise you people need to reinstall the things and do the installations. Okay, now the installation is successfully done. Okay, I'm able to use the OpenCV library. So I shown you people how to install it, and I shown you here how to import that here. Any queries regarding this? Okay. So now let me ask a simple question here. Ganesh, you have any idea about MATLAB? MATLAB. If you want to read a file, I'll take a variable to read that file and store it in a variable like I equal to cv2 dot imread is the function to read the file. Okay, so then you need to mention the file name. So let me take the file name here. So what is the file name? Here is the my current folder. Where is that? Machine learning. MLABTC. So here is the images RCB team. I am going to read this file which is in the JPG format. So let me take that file into account here. RCB team.jpg. Okay, it is directly available here with the name RCB team.jpg. Okay, lowercase this one. Okay, so next, print reading file completed. And image has shape equal to comma I dot shape. Okay, so reading the file completed. The image has a shape 720 rows, 1280 columns and 3 pages. This is what the meaning. Okay, 720 rows, 1280 pages, 280 columns and 3 dimension. Okay, so here if I'm writing, okay, row, column and dimension equal to, okay, I dot shape. Okay, so then so if you print R, it will be number of rows, C number of columns, D the dimension. See, D indicates dimension, 3 indicates it has got a 3 pages. Like if I'm taking a an image, so let me show you. If you're taking an image, so image is represented with number of rows, okay, rows and number of columns. Okay, so each point here, okay, corresponds to the row and a column. This is the first row and first column. So then one more pixel over here, one more over here, one more like this. This is in the second row, first column. This is in the first row and second column, second row, second column, like that, so on up to the last row and the last column. So these are the picture elements. So picture elements stand for the numerical values sensed by the sensitivity of the color by a particular sensor, which is basically used in your cameras. Okay, so cameras will reflect the light intensity. So if the light intensity is more, the sensitivity also increases. So due to increase in the level, there will be variations in the input voltage levels. That voltage levels measured will be considered as picture elements. They actually represent the color. Okay, so normally there will be four types of sensors will be there. So one is red, green, blue, and there will be one more kind of sensor for the black and white sensor will be there. Okay, in olden days we had only black and white sensors. So recently most of the mobiles will have a RGB sensors. So when you're reading it from three different sensors, you will get three different pages. You will get three different pages like this, and one more like behind this one. Okay, so this particularly is for the red page, and this will be for the green page, and this is for the blue page. Okay, so that means one particular point is represented with the help of three different color values: red, green, and blue. Combination of these three makes the final image. So this final image, if I'm taking it, so here each point is represented with the three different values like red page, green page, and blue page. Okay, so that's why color images will have a three pages here indicates. Okay, but so this is in MATLAB. This is how the syntax goes on. When you read it, it reads RGB values, but in Python it reads in the reverse order, that is blue, green, and red format. It reads like that. Okay, so let's move on to the next thing. If you want to display the image, you need to create a window for that. cv2 dot named window. So this function will does the task named window, where W is capitals. Okay, just need to remember. You need to give the title for the image. Say like first image. That is what the name I'm giving it. Okay, so or else I'll give the RCB image. Like this is the title I'm giving it to the window. This is the window name. Okay, so then cv2 dot, sorry, cv2 will be in the lowercase, cv2 dot window. So totally completely in capital letters, window underscore normal. So this will just create an window. This will create the creates empty window. This method will create an empty window. Now in order to display that, you will write cv2 dot imshow function with the variable. You need to mention the first the window name as RCB space image. This is the window name. Then comma, you need to mention the variable which is having a image data. So this is the variable which is having the image data, right? So we are going to pass that variable here. So once I execute this one, automatically a window will appear for the displaying the image. Here you can see that you are having it, but so there is an error here, not responding and all, because we need to give some time for the display to occur. Okay, for image to appear on the window, we need to give some delay for that one. Okay, so if you don't give it, so there will be issue like this will happen. So how to give that and all, we'll see that now. So let me close this, close and close the program. Certain case these kind of errors will start appearing it, because intentionally I shown this, because So if you run this much of code and then if you're trying to give the delay, so this is going to be problematic always. Okay, so even the kernel has stopped, we need to restart it. So we have to beginning from the one more time, we need to execute everything. So now instead of directly going display after immediately display, we will give the wait function cv2 dot wait key of 0. 0 indicates infinite delay. Okay, infinite delay. So we are giving the delay for infinitely. Okay, to close this, I will execute cvt dot destroy all window. Okay, here 0 indicates if you unless you press any key from the keyboard, the display will be there. Okay, but after that, what next we need to do is we need to close that window, like the figure window which is appearing separately, so that will be closed separately. Okay, so close windows. If you want, you can mention the which window you need to close it. So this is the basic command which will close all the figures. So let me execute this one now. Has no attribute, wait key function is not there. Okay, here k is capital. So these are some mistakes what usually happens. Okay, so we are getting the display over here. Okay, so now you can see the display will be there forever. If you try to write anything, if you try to execute anything, okay, so print display completed, displaying image completed. If you execute also, this statement is not appearing because the loop is in here only till the time you close this one, nothing, no other actions can be performed. How to close this one? As mentioned here, it is waiting for the key 0. 0 means any key. If you unless you press, so infinite delay till we press any key from the keyboard. Okay, so closes the figure window or image. Okay, so let me click here. Now I'm clicking here or pressing with the space button. As soon as I pressed space, the execution closed, it went to the next line. In next line we have written that destroy all windows, so it will close the windows, then it will come and execute this statement, okay, which we tried earlier. That statement will be executed. Okay, so this is how you will do the display, and what is the use of wait key function, what is the use of destroy all windows command. Okay, so let me show you some other methods. Okay, even I'll repeat this same step. Okay, in this case the delay I'll be yes, tell me. ಹಾಂ, ಇಲ್ಲ ಆನ್ಲೈನ್ ಅಲ್ಲ ರೀ, ಇಲ್ಲಿ ಸ್ಟೋರ್ ಮಾಡಿದ್ದೀನಲ್ಲ ನಾನು. ಇಲ್ಲಿದೆಲ್ಲ RCB ಟೀಮ್ ಅಂತ ಇಮೇಜ್ ಸ್ಟೋರ್ ಮಾಡಿದ್ದೀನಲ್ವ, ಡೌನ್ಲೋಡ್ ಮಾಡಿದೆ. ಅದಕ್ಕೋಸ್ಕರ ನನ್ನ ಹತ್ರ ಯಾವುದು ಈ ಸಿಸ್ಟಮಲ್ಲಿ ಯಾವುದು ಇಮೇಜಸ್ ಇದ್ದಿಲ್ಲ, ಸೊ ಜಸ್ಟ್ ಡೌನ್ಲೋಡೆಡ್ ಇಟ್. ಓಕೆ, ಸ್ಯಾಂಪಲ್ ಪಿಕ್ಚರ್ಸಲ್ಲೂ ಯಾವುದೂ ಇಲ್ಲ ರೀ ನಮ್ಮ ಹತ್ರ. ಓಕೆ, ಸೊ ಐ ಡೌನ್ಲೋಡೆಡ್ ಇಟ್. ಯು ಕ್ಯಾನ್ ಡೂ ದಟ್ ಡೌನ್ಲೋಡಿಂಗ್. ಓಕೆ, ಅಥವಾ ನಿಮ್ಮ ಹತ್ರ ಯಾವುದೇ ಇಮೇಜಸ್ ಇದ್ದರೂ ಅದನ್ನು ಟ್ರೈ ಮಾಡ್ಬೋದು. ವಾಟ್ ಎವರ್ ದ ಇಮೇಜಸ್ ಯು ಹ್ಯಾವ್ ಇಟ್, ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ಟ್ರೈ ಫಾರ್ ದೋಸ್ ಇಮೇಜಸ್. ಓಕೆನಾ? So now if I am writing 5000, it is equivalent to delay of 5 seconds. 0 means it will wait for infinite times. So now if I am writing 5000, so the delay will be for 5 seconds. 1000 means 1 second. Now executes. So after 5 seconds automatically, so it will move to the next step. Okay, so and it will close the window. Now let me see that. So only it will be open for 5 seconds. Can count down. Yeah, after 5 seconds that display got disappears, because we have written this destroy all windows command. If you not written this one, still that image will be there. Okay, but you can still do the other operations. If you, even if you're not closing it, you can do the further operations. So that's how you can do that. Use the wait key function to set your own delays. There are other libraries as well, like if you want to for the display and all, you can still use the Matplotlib. Matplotlib also can be used for display purpose. Okay, you can also use the PIL library. Okay, library for images. ಇದೊಂದು ಕೂಡ ಇದೆ. ಓಕೆ, ಸೊ ಪಿ ಐ ಲೈಬ್ರರಿ ಅಂತಲೇ ಇದೆ. ಇನ್ನು ಬೇರೆ ಇನ್ನೊಂದು ಲೈಬ್ರರಿ ಪಿಲ್ಲೋ ಅಂತ ಕರೀತಾರೆ. ಓಕೆ, ಸೊ ಆ ಥರ ಲೈಬ್ರರೀಸ್ನ ಕೂಡ ಯೂಸ್ ಮಾಡ್ಬೋದು ನಾವು ಇಮೇಜ್ ಪ್ರೊಸೆಸಿಂಗ್ಗೆ. ಓಕೆನಾ, ಫೈನ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಅದರ್ ಬೇಸಿಕ್ಸ್ ಆಲ್. ಸೊ ಲೆಟ್ ಮೀ ರೀಡ್. How do we read it? So I'll begin from the first. Okay, import cv2. Then what you'll do is I'll write i1 equal to, okay, cv2 dot imread of the file name rcb team dot jpg. This is the file. I2 equal to cv2 dot imread. Okay, so same rcb team I'm writing it, rcb team dot jpg, okay, comma 0. I3 equal to cv2 dot imread of rcb team dot jpg, comma 1. Okay, so let me read all the three all same image only I'm reading it, but here I didn't mention any number, but here I mentioned 2 numbers. Let me see what is the difference between all of them. Okay, so I'm going to create 3 different images. RCB image 1, 3 windows I'm going to create it. Okay, so here I'm writing it as 2, image number, window number 2 and window number 3. 3 windows will be created. Okay, so here image 1 I1, here I2, I3. So wait for 3 seconds. I want to close, destroy. Okay, so this time I'm going to destroy a particular window. I don't want to destroy all the windows. I'm going to destroy this first window. So just you need to mention that one. Okay, destroy window. So then cv2 dot wait key. After that I will wait for further 5 seconds. Okay, so after that I'll display destroy all the windows, like both remaining 2 windows will be destroyed. Destroy all windows. Okay, sorry, this is wrong. Destroy all windows. One mistake here, spelling mistake. Destroy all windows. And here I forgot to mention the problem was I mentioned RCB image 1 for everything. So what will happen is all the 3 images will be displayed on the only one window, not on the other 2 images. That actually you saw that, it seems. Okay, The display came on a single window, but now this time we can expect it to appear on a 3 different windows. You can see here. So they also disappeared. Let me increase the delay so that we can clearly see that. 10,000, and here again further 10,000. You can see we have total 3 windows. In RCB image 1, so this is a regular one, we had a color image, but in RCB 3 we had this I3 image. In this 2 we have this grayscale image. So what happens means, when you read with 0 indicates, so this is a grayscale read. This will read the grayscale image of the same image. Okay, this is the color version, color image. Even this is as per the color image. By default it will read the color image. You can specify whether to read the grayscale image or a color image. So these details you can do that one. Okay, and also I shown the one more method, like how to use the destroy window. Like you can specifically tell which window to be closed, that you can decide it here. Any questions here? Okay, so further, so we'll move on to the next thing, some other basics. If you, after reading it, if you want to write an image, okay, so now I have a grayscale image right here in I2 grayscale image there. I want to write this image to a new file, so that I can do that one. Okay, so writing to a file. So to write an image, okay, we can write cv2 dot im write function. Okay, so you are going to mention the file name. Okay, so gray RCB team. Okay, dot extension, you can mention the extension which you want to like it. Okay, so I want it in the PNG format. Okay, so then comma, the variable which you want to use it. Okay, so I'm going to use that variable I2. I2 is actually having a grayscale image. So let me do this one. So this has completed, and you can see actually here gray RCB image will be there available here, gray RCB team.png. Okay, so if I open the folder, I have that image, gray RCB team. Okay, anyways it is not visible here. If I want, I can, yeah, you can see a grayscale image is there. Clear? So that's how I can write the images. Read, write, and display. This much we have completed now. So let me try something else. Okay, if you want to display the image using the Matplotlib, that also can be done. Okay, say like now I'll import the from Matplotlib lib.pyplot import like just import matplotlib.pyplot as plt. After that plt.im show, like I'll mention here I3 image. Okay, if you want to label it, you can do that labeling. Okay, plt.show. Yes, you can see here, like, but actual colors will not be clearly clearly appears here. So but that we can control. Okay, so that things will be covered later stage. Like if you want to, like, you can refer the documentations for that one. Okay, so 8-bit for representation. So in black and white we require 0 and 1 as the color value. 0 represents black, 1 represents white, so we require just only 1 bit. So but these zeros and ones are actually binary zeros and ones, so they are also called as binary images. Okay, and in grayscale images we have a 8-bit representation starting from 0 to 255. That means only unsigned integer values are available. So here 0 represents the black color, 255 represents the white color, and 128 the mid color, that is gray color. Okay, so total we have a 256 color values. Total we have 256 color combinations. Okay, mixture of black and white. So but in color images we have the 3 color components to represent a one color. Okay, each color has got a 8-bit and uint 8 type, unsigned integer. Okay, so that means total we have, so 24-bit representation. Okay, 24-bit representation. 8-bit means 256 colors into 256 into 256, so that is equivalent to 16 million, okay, color combinations in color images. Okay, so totally 16 million color combinations are available for a 8-bit type. So there are advanced versions which can have a 24 to 32-bit, like 4 color components, then the combinations will be increases to 65 millions. Like that you can increase the color, like more the bits, better is the color representation, but at the same time it eats more memory. Okay, so depending on what you need, whether you want the less memory and the better results, so go for this standard method, or else if you want your application involves only the very high definition colors, okay, so then use the higher number of bits, so but at the expense of increased memory. Okay guys, so that's some basic introduction to the images and how to read them and write them in the using, oh, sorry, here guys, I need to repeat it. So here, in order to read image you will use this command, but after reading it, color images, we can separate the color components like this. First page always belongs to the blue, second page will be for the green, third page will be for the red. This is in the Python. Okay, but in MATLAB this will be reverse. First page will be for the red, second is for the green, third will be for the blue in the MATLAB case. So now since we are using Python, we will stick to this one. Now, so if you combine these three, you will get the color image back. But most of the image processing algorithms are built for two-dimensional arrays. But I is a 3D array. I is a 3D array, not a, our image is a 2D image only, but it has got a 3-dimensional matrices to represent the color image. So we need to separate them, so in order to perform the operations. Okay, because the reason is we have a methods built for the 2 dimensions only. Okay, for this purpose. Now if you want to display them separately, we can do that displays. So when we have these windows separately displayed, like blue, green, red, they will appear as a color windows, grayscale images. The reason is this is a 2-dimensional, and in 2D we have the range only between 0 to 255. So only 8-bit representation will be there. But the same 8-bit representation when combined as a color image, so you will get a color values like this. Okay, but when we reviewing individual pages, they looks like a grayscale images. Okay, so let me stop this one now. Wait key, some error is there, dv2. Okay, sorry, it is cv2, and no attribute destroy all windows. Okay, so we are able to see that how to extract the color image pages. We saw that just now. Okay, so this is required for the purpose, like if I ask you one question here to Banashankari, ಈಗ ಕಲರ್ ಇಮೇಜ್ ಅಂದರೆ ಎಕ್ಸಾಂಪಲ್, ಈಗ ನಾನು ಇಲ್ಲಿ ಹೇಳಿದೆ 3 ಪೇಜಸ್ ಇದೆ ಅಂತ ಹೇಳಿದೆ ಅಲ್ವಾ. ಬ್ಲೂ ಪೇಜಲ್ಲಿ ಏನು ರೇಂಜ್ ಇರುತ್ತೆ ಹೇಳ್ರಿ? ಇಫ್ ಯು ಆರ್ ಟೇಕಿಂಗ್ ದ ಬ್ಲೂ ಪೇಜ್, ಪಿಕ್ಸೆಲ್ ವ್ಯಾಲ್ಯೂಸ್ ಏನು ರೇಂಜಲ್ಲಿರುತ್ತೆ? 0 to 255 ರೇಂಜಲ್ಲಿರುತ್ತೆ. ಓಕೆನಾ? ಸಿಮಿಲರ್ಲಿ ಈಗ ಅದೇ ನಾವು ಗ್ರೀನ್ ಪೇಜ್ ತಗೊಂಡ್ರೆ ಸೇಮ್ ಅಲ್ವಾ. ಸೊ ಇಲ್ಲಿ ಕೂಡ 0 to 255 ಇರುತ್ತೆ. ಓಕೆ, ಈಗ ನೆಕ್ಸ್ಟ್ ರೆಡ್ ಪೇಜ್ ತೊಗೊತೀನಿ. ಓಕೆನಾ, ಇಲ್ಲಿ ಪಿಕ್ಸೆಲ್ ವ್ಯಾಲ್ಯೂಸ್ ಏನಿರುತ್ತೆ 0 to 255 ಇರುತ್ತೆ. ಓಕೆ, ಈಗ ನಾನು ಇಲ್ಲಿ ಒಂದು ವ್ಯಾಲ್ಯೂ ಬರಿತೀನಿ, ಒಂದು ವ್ಯಾಲ್ಯೂ ಅಂತ ಬರಿತೀನಿ. ಐ ವಿಲ್ ರೈಟಿಂಗ್ ಹಿಯರ್ ದ ವ್ಯಾಲ್ಯೂ 0. ಇಲ್ಲಿ ಬರೆದಿದ್ದೀನಿ 255 ಅಂತ ಬರೆದಿದ್ದೀನಿ. ಇಲ್ಲಿ ಕೂಡ ನಾನು 255 ಅಂತ ಬರ್ತೀನಿ. ಇದು ಯಾವ ಕಲರ್ ಅಂತ ಹೇಳೋಕ್ಕಾಗುತ್ತಾ ನಿಮಗೆ? 0 ಅಂದರೆ ಯಾವ ಕಲರ್ ಹೇಳ್ರಿ? ಇಲ್ಲಿ ನೋಡಿ ಹೇಳ್ರಿ, 0 ರೆಪ್ರೆಸೆಂಟ್ಸ್ ವಾಟ್ ಕಲರ್ ಅಲ್ವಾ. ಸೊ ದಿಸ್ ರೆಪ್ರೆಸೆಂಟ್ಸ್ ದ ಬ್ಲ್ಯಾಕ್. ಇದು ಯಾವ ಕಲರ್ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡುತ್ತೆ? 255 ಅಂದರೆ ಇಲ್ಲಿ ನೋಡ್ರಿ ಏನಿದೆ ವ್ಯಾಲ್ಯೂ, ವೈಟ್ ಅಲ್ವಾ. ಸೊ we are now representing this color represents these values represent the black and white values. But this is the case when you have a separate blue page, separate green page, separate red page iddag matra. But when you combine all the three, when we combine, okay, so this represents black, white and white when they are separate pages. But when combined, okay, so the same represents, okay, darkest blue. The same represent darkest blue color. Okay, so then highest green, highest green. So then here highest red. ಇದು ಮೂರು ಕಂಬೈನ್ ಆಗುತ್ತಲ್ವಾ ವೆನ್ ದೇ ಆರ್ ಕಂಬೈನ್ಡ್. ಅಂದರೆ ಈಗ ರೆಡ್, ಹೈಯೆಸ್ಟ್ ಗ್ರೀನ್ ಆ್ಯಂಡ್ ಡಾರ್ಕೆಸ್ಟ್ ಬ್ಲೂ, ಇದು ಮೂರು ಕಂಬೈನ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಯು ವಿಲ್ ಗೆಟ್ ಎ ನ್ಯೂ ಕಲರ್. You will get a new color. Okay, so that new color will be your representation of that particular page. Okay, ಅದಕ್ಕೋಸ್ಕರ ನಾವು ಇದನ್ನ ಡಿಸ್ಪ್ಲೇ ಮಾಡಿದಾಗ ಕಲರ್ ಇಮೇಜ್ ಕಾಣಿಸ್ತಾ ಇತ್ತು. ಸಪ್ರೇಟ್ ಡಿಸ್ಪ್ಲೇ ಮಾಡಿದಾಗ ಏನಾಗ್ತಿತ್ತು, ಈ ಥರ ಆಗ್ತಿತ್ತು. ಓಕೆನಾ, ಬ್ಲ್ಯಾಕ್ ಆ್ಯಂಡ್ ವೈಟ್ ಇಮೇಜ್ ಥರ ಕಾಣಿಸ್ತೈತೆ, ಗ್ರೇ ಸ್ಕೇಲ್ ಇಮೇಜ್ ಥರ ಕಾಣಿಸ್ತಾ ಇತ್ತು. ಈ ಎಕ್ಸಾಂಪಲ್ 255 0 255 255 ಅಂದರೆ ಇಟ್ ವಿಲ್ ಬಿ ಲೈಕ್ ಆಲ್ಮೋಸ್ಟ್ ರೆಡ್ ಮತ್ತು ಗ್ರೀನ್ ಕಾಂಬಿನೇಷನ್. ಯು ವಿಲ್ ಗೆಟ್ ಯೆಲ್ಲೋ ಕಲರ್ ಬರುತ್ತೆ ನಿಮಗೆ ಆಲ್ಮೋಸ್ಟ್. ಓಕೆನಾ, ಸೊ ಅದೇ ಥರ ಬೇರೆ ಬೇರೆ ಕಲರ್ ಕಾಂಬಿನೇಷನ್ಸ್ ಬರ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ನೀವು ಪೇಂಟಲ್ಲಿ ಚೆಕ್ ಮಾಡ್ಬೋದು. ಓಕೆ, ಎಡಿಟ್ ಕಲರ್ಸ್ ಅಂತ ಕೊಟ್ಟರೆ ಇಲ್ಲಿ ಕಾಂಬಿನೇಷನ್ ಹೇಳುತ್ತೆ ನೋಡಿರಿ, ರೆಡ್, ಗ್ರೀನ್, ಬ್ಲೂ. ಈ ವ್ಯಾಲ್ಯೂ 237 28 36 ಇದ್ದರೆ ಇಟ್ ರಿಪ್ರೆಸೆಂಟ್ಸ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಕಲರ್. ಓಕೆನಾ, ಎಕ್ಸಾಂಪಲ್ ಈಗ ನಾ ಎಲ್ಲೋ ತಗೋ, ಸೊ ಐ ಆಮ್ ಪುಟ್ಟಿಂಗ್ ಇಟ್ ಹಿಯರ್ ಎಲ್ಲೋ ಆಲ್ಮೋಸ್ಟ್. ಈಗ ನೋಡಿರಿ ಏನಿದೆ ವ್ಯಾಲ್ಯೂ, ಕಂಪ್ಲೀಟ್ ಎಲ್ಲೋ. ಈಗ ನೋಡ್ರಿ ಏನು ಬಂತು, 255 255 0 ಎಲ್ಲೋ ಬಂದಿದೆನಾ, ಸಾಲಿಡ್ ಎಲ್ಲೋ ಇದೆ ಅಲ್ವಾ. ಬಟ್ ಇಲ್ಲಿ ಲುಕ್ ಅಟ್ ಇನ್ ಅವರ್ ಪ್ರೋಗ್ರಾಮ್, ಬ್ಲೂ, ಗ್ರೀನ್, ರೆಡ್. ನಾನು ಏನು ಹೇಳಿದ್ದೀನಿ, ಹೈಯೆಸ್ಟ್ ಗ್ರೀನ್ ಇದೆ, ಹೈಯೆಸ್ಟ್ ರೆಡ್ ಇದೆ, ಲೋಯೆಸ್ಟ್ 0. ಅಂದರೆ ಇದು ಯಾವ ಕಲರ್ ಆಗುತ್ತೆ, ಯೆಲ್ಲೋ ಕಲರ್ ಆಗಿ ಡಿಸ್ಪ್ಲೇ ಆಗುತ್ತೆ ಕಂಬೈನ್ ಮಾಡಿದಾಗೆ. ಅದೇ ನೀವು ಕಂಬೈನ್ ಮಾಡಿದಂಗೆ ಸಪ್ರೇಟ್ ಡಿಸ್ಪ್ಲೇ ಮಾಡಿದರೆ ಇದು ಬ್ಲ್ಯಾಕಾಗಿ ಕಾಣಿಸುತ್ತೆ, ಇದು ವೈಟಾಗಿ ಕಾಣಿಸುತ್ತೆ, ಇದು ವೈಟಾಗಿ ಕಾಣಿಸುತ್ತೆ. ಓಕೆನಾ, ಸೊ ಅದೇ ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ಹೇಳ್ತೀನಿ ನಿಮಗೆ. ಇದು ಹೇಳಿ 128. ಓಕೆ, 128 0. ಇದು ಯಾವ ಕಲರ್ ಕಾಣಿಸ್ಬೋದು, ಇದನ್ನು ನೀವು ಸಪ್ರೇಟಾಗಿ ಡಿಸ್ಪ್ಲೇ ಮಾಡಿದ್ರೆ ಹೆಂಗೆ ಕಾಣಿಸುತ್ತೆ ರೀ, ಗ್ರೇ. ಓಕೆ, ಇದು ಹೆಂಗೆ ಕಾಣಿಸುತ್ತೆ, ಮತ್ತು ಗ್ರೇ ಕಾಣಿಸುತ್ತೆ. ಅಂದರೆ ಇದು ಯಾವ ಕಲರ್ ಕಾಣಿಸುತ್ತೆ, ಬ್ಲ್ಯಾಕ್ ಕಲರ್ ಕಾಣಿಸುತ್ತೆ. ಬಟ್ ಅದನ್ನೇ ನೀವು ಕಂಬೈನ್ ಮಾಡಿ ಡಿಸ್ಪ್ಲೇ ಮಾಡಿದರೆ ಮಿಡಲ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಬ್ಲೂ, ಮಿಡಲ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಗ್ರೀನ್. ಓಕೆ, ಸೊ ದೆನ್ ನೋ ರೆಡ್ ಕಲರ್. ಅವಾಗ ಏನಾಗುತ್ತೆ ನೋಡೋಣ, ಇಲ್ಲಿ ಒಂದು ತೋರಿಸ್ಬಿಡ್ತೀನಿ ನಿಮಗೆ. ಸೊ 128 128 ಮಿಡಲ್ ಕಲರ್ ಆಫ್ ಬ್ಲೂ. ಓಕೆ, ಎರಡು ಕಂಬೈನ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಸ್ವಲ್ಪ ಈ ಥರ ಗ್ರೀನ್ ಕಲರ್ ಬರ್ತೈತೆ ನೋಡ್ರಿ. ಓಕೆನಾ, ಸೊ ಇದು ಬ್ಲೂ 0 ಇದೆ, ಸಾರಿ ಬ್ಲೂ ಅಲ್ವಾ, ಅಲ್ಲ ಬ್ಲೂ 128 ಇದೆ, ಸಾರಿ ಇದು 0 ಇದೆ. ನೋಡ್ರಿ ನಿಮಗೆ ಯಾವ ಕಲರ್ ಬಂತೀಗ. ಸೊ ಯು ಗಾಟ್ ದಿಸ್ ಕಲರ್ ನಾವು. ಓಕೆ 0 128 128. ಓಕೆ ನಿಮಗೆ ಗ್ರೀನಿಶ್ ಬ್ಲೂ ಬಂದಿದೆ, ಯಾಕಂದರೆ ಗ್ರೀನ್ ಮತ್ತು ಬ್ಲೂ ಮಿಕ್ಸ್ ಆಗಿದೆ, ರೆಡ್ ಮಿಕ್ಸ್ ಆಗಿಲ್ಲ. ಸೊ ಅಲ್ಲ ಗ್ರೀನಿಶ್ ಬ್ಲೂ ಕಲರ್ ಬರ್ತಾ ಇದೆ ನಿಮಗೆ. ಓಕೆನಾ. ಸೊ ಯು ಕಾಲ್ ದಟ್ ಆ್ಯಸ್ ಎ ಲೈಕ್ ಓಷನ್ ಬ್ಲೂ ಅಂತ ಕರಿತೀರಿ ನೋಡ್ರಿ. ಓಕೆ ಆ ಕಲರ್ ಬಂದಿದೆ ಅದು. ಸೊ ಲೈಕ್ ದಟ್ ಯು ಕ್ಯಾನ್ ಗೆಟ್ ಡಿಫ್ರೆಂಟ್ ಕಲರ್ ಕಾಂಬಿನೇಷನ್ಸ್. ಓಕೆನಾ. ಸೊ ದಟ್ ಕಾಂಬಿನೇಷನ್ಸ್ ನೀವು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಬೋದು. ಏನಕ್ಕೆ ಸಪ್ರೇಟ್ ಮಾಡಬೇಕಂದ್ರೆ ರೀಸನ್ ಏನಂದರೆ, ಡೈರೆಕ್ಟಾಗಿ ನಾವು ಮೆಥಡ್ಸ್ನ, ಇಮೇಜ್ ಪ್ರೊಸೆಸಿಂಗ್ ಮೆಥಡ್ಸ್ನ ವಿ ಕೆನಾಟ್ ಅಪ್ಲೈ ಆನ್ ಟು ದಿಸ್ ವೇರಿಯಬಲ್ ಕೆಲವೊಂದು ಕಡೆ. ಹಾಗಾಗಿ ವಿ ಶುಡ್ ನೋ ಹೌ ಟು ಸಪ್ರೇಟ್ ದೆಮ್. ಕಂಬೈನ್ ಮಾಡೋದು ಯಾವ ಥರ ಕಂಬೈನ್ ಮಾಡ್ತೀರಿ ಅನ್ನೋದು ಗೊತ್ತಿರಬೇಕಾಗುತ್ತೆ ನಿಮಗೆ. ಓಕೆನಾ. ಸೊ ಫೈನ್ ಗೈಸ್, ಥ್ಯಾಂಕ್ ಯು. ಬನ್ನಿ. ಎನಿ ಕ್ವೆಶನ್ಸ್ ಹಿಯರ್? ಎನಿಬಡಿ ಎಲ್ಸ್? ಯಾರಿಗಾದ್ರೂ ಕ್ವೆಶನ್ಸ್ ಇದೆನಾ? Right. So here I am creating a filter kernel with all the values 1. So to make it as a averaging filter, AF equal to, okay, so instead of directly creating like this with all the values 1, I'll create with all the values 1 and convert this to a floating point format, float32 format, and divide all the elements by 25. Okay, so that means, and if I need to print AF, so this is how it looks like with all the values as 0.004. so this I am considering it as a averaging filter. So this I'll use it with my input image and pass it through a filter. Like you can see the difference. Okay, filtered image equal to fi equal to cv2 dot filter. It requires original image I, comma, then -1, comma, what is the kernel? Kernel is AF, that is a filter. Okay, so this is a format, so which I am going to use it now. After filtering, okay, as no attribute filter 2-dimensional, okay, 2D. So applied. Now to display this image, okay, so I'm going to use the show you like how to use the, like, let me see how to use the OpenCV cv2.im show, comma, original, comma, I, then cv2.im show of filtered, comma, fi, then cv2 dot weight key of 0, cv2 dot destroy all windows. So this is the filtered image and this is the original image. You can see that original image is having a more clear and crisp layouts, but whereas averaging filter, what it did is it suppressed the image sharpness. Averaging filter role is that one, it suppressed the sharpness of your image. So for this purpose we will be using the averaging filter. So this is the how you can use the averaging filter here. So this is the function, inbuilt function called as filter2d, which can be used to filter out the things. Okay, so like this there are many things are there which are involved in the image processing. Like you can have a edge detection. Okay, so edge detection, then morphological operations, so then you can go through other types of filters, then image conversion, like gray to color, color to gray, color to black and white, and so on. Okay, then image thresholding, image enhancement. Okay, like this you have many other topics which, if you like to, you can refer this particular documentation and read it yourself. As OpenCV is not part of your ML internship, but still I given you the basic introduction, like how to install the library and how to use this library to read the images and to write the images, to display the images, and how to use the basic functions of the uh, image processing library, that is OpenCV library. Okay, so that's it for the about the OpenCV library. Like if you have any questions regarding the same, you guys can ask me. Okay. Like here I'll just one more thing I'll show you, like which will be useful. Like if we are using Matplotlib, okay, import Matplotlib dot pyplot as plt dot subplot of 121 comma plt dot imshow of original image comma plt dot title as original image, then plt dot subplot of 122, that means first row second columns, okay, and one row only, in that two columns I'm creating it. Like so display will appear as one beside the another one, plt dot imshow of fi comma plt dot title average filtered image. So that's the title I'm using it. So then let me show that plt dot show your image. So here you can see here the image is appearing one beside the another one. So this is the average filtered image, this is your original image. So using the Matplotlib also you can do the display and all. And if you want to apply the noise and all, I can use that noise functionality also. So there is a methods using that you can, if you want to add the noise, you can add the noise, like you can add the adding noise using sklearn library. So for testing purpose and all, if you want to just add yourself the noise to the images and you want to try the removing the noise and all, you can try that as your basics of image processing concept. Okay, I'll just show one example on that one. Say like if you want to, I want to add the salt noise, you can add a pepper noise, you can add salt and pepper, like that many noises you can try it. Okay, so now if I want to add a salt and pepper both the noises, I can take it as a sp. Okay, sk image, there is a library called as sk image library, not learn. Sklearn is basically used for the ML basic ML techniques. Okay, here sk image library will be used for the image processing purpose. Sk image dot utilities util dot random underscore noise Okay, there are many noises are there, like a Gaussian noise, white noise, like many are available. I'm going to mention here the noise type will be pepper noise or a salt and pepper noise. Okay. Now if I'm selecting only the pepper noise, I'll take it for my original image, comma, mode equal to, if I'm writing pepper, if I'm writing pepper, I can add the pepper noise to that, PPPER. Okay. And if I'm trying to display that image, here I'll display original image, and here I'll display SP image, noisy image. SK image is not defined. 1 minute. Okay, I need to import it first. Import SK image. Okay, so here comes the difference is not clearly visible. So what I'll do is, let me show you that image, I and SP, noisy. See here, the pepper noise is visible here clearly, dots are visible. In the original image it is not visible here, it is very clear. You can see these hands with the pepper noise. Pepper noise means black dots will be more visible. Okay. So then later on you can use some methods to remove this noise also. Later on you can use some of the image processing techniques to remove this noise. Okay. So that you can try it on your own if you like to. So that's it for the day, guys. Any